Signori e signori, buongiorno.
Ladies and gentlemen, good morning. It is a great honor and a pleasure to be here. Today, Italy is celebrating the 2nd of June, Republic Day, and it is a great honor to be here. And I am a local coordinator, and I'm happy and proud to introduce Professor Chad Jones. Chad Jones is one of the greatest, most influential economists that research economic growth. And today, he holds a chair at Stanford University. He studied at MIT, has a PhD with Olivier Blanchard. He studied with him, one of the most influential economists of the previous generation. And then he went to Berkeley and became Stanford professor at the Stanford Business School. And he's holding the chair of economics at Stanford today. So he studied and he shaped the basic of macroeconomics and our growth model. And I would like to give you an idea of how Chad Jones is influential. So just give me a minute or two maybe to tell you the story of a theory of modern growth, because I believe that Chad Jones is the leader of the third generation of economists. So if you have studied, the first generation was Bob Solo's generations. The 50s, he wrote the growth model, and that was the classic model of growth that was found in economics books all over the world. And we started to shape the theory of economics since that first generation. So growth as a phenomenon that has been studied, and Bob Solo received several awards, and in 1987 the prize for economics. Then there's the second generation. The second generation, Chad and I, we have almost the same age. We were students at that time. So Paul Roman and Philippe Guillon. Philippe Guillon was here just yesterday. And this second generation introduced the fundamental concept of endogenous growth. So it is not external to the economic system. It is something that is not coming from the above. It is something that is within the system. So this revolutionized the whole analysis and the growth model. Paul Roman won the Nobel Prize for Economics in 2018. Then comes the third generation. The third generation, and I have no doubts about it, I'm really passionate about growth, and I've been researching the labor market, but now I'm also teaching, and there are many students to studying and researching economic growth, and I'm teaching quite a lot, and I'm trying to research as much as I can, and I'm inspired by Chad Jones because he brought things to the next level. It is much more realistic. So its contribution from the end of the 90s until today added this new growth model that is second generation and growth dependent from the dimension of the country in a way. And this is something the US is growing at a much faster rate because, not because it's bigger than Luxembourg, but the model is different, so the exogenous model. And growth is also shaped by the growth of the population. That is an exogenous phenomenon. So we have tried to read his research, and we understood that there was a change in the 90s. So ideas became fundamental in the theory of growth after Paul Romer, and then Chad Jones writing about Paul Romer. That is incredible. That is the best way to understand Paul Romer. So go read Chad Jones, please, to better understand this. So there's a whole generation of ideas that are a fundamental asset for growth, and that seems to be quite abstract at first, but Chad clarified that, and the recent research helped us to understand. So we have a number of researchers and in several sectors. So today we have more ideas. So today we understand better how difficult it is to generate new innovative ideas in many sectors and fields. So let's say with transistors, and then there are several other examples. So Chad's contribution was fundamental. I don't want to steal too much time. So in recent research, Chad is also researching population. So growth depends on the growth of population, but that is also an endogenous phenomenon. So that is in today's world, we have a low fertility rate overall, and especially in Italy. So there's a negative trend when it comes to population growth. So in one of his recent papers, The End of Economic Growth, that is quite telling and a little bit unsettling to read all that. So when we think about the new generation, Chad Jones introduced something that was quite unsettling. So the empty planet equilibrium, an empty planet in order to achieve that equilibrium. That is fascinating. It sounds almost like science fiction, but it is a really, really practical theory. So we are deeply honored to have Chad Jones here today. The floor is yours.
Wonderful. Well, thank you so much, Pietro, for the kind introduction. It's really a pleasure to be here. This is my first trip to Turin, and I've thoroughly enjoyed it, and especially the festival and all the incredible talks. I think I was telling several people the university system in the United States is under some pressure given current events, and I think we could learn a lot from the festival and maybe have some of these celebrations of intellectual activity and share it with the public more. So I will take away some great ideas from this visit. Yeah, so the paper I want to talk about today is on population growth and economic growth, and I want to make 3 points during my time. The first is to highlight this link between population growth and economic growth that Pietro talked about, and consider what happens when fertility rates are below replacement and populations are declining rather than rising. So that's related to this End of Economic Growth paper that Pietro mentioned. And then kind of these points go in increasing order of speculativeness. So the second point I want to make is some data work I've done with some colleagues recently about measuring economic growth. And what if we measure economic growth to take into account the fact that having lots of happy, flourishing people seems like a good idea? So that'll be the second point. And then the third point, most speculative, which is where the title came from for my session. What does the optimal population of the world look like? How many people should we have? And that's obviously extremely speculative. But I've learned a lot by working on these topics, and hopefully, if you view them in the right way as sort of a thought experiment about how the world works or how the world might work, I at least hope to provoke you with some new thoughts. Okay, so first let me highlight this kind of what I think of as a kind of surprising link between population growth and growth in living standards. So here's a graph of GDP per person in the United States. You could see the signature of exponential growth, the ever-increasing slope associated with the curve. The average person in the United States today is about 16 times better off than the average person 150 years ago. So this is the economic growth we've experienced. Economists love to put this on a different scale, so it's the same graph, but you'll notice rather than going up 10, 20, 30, 40, the axis here doubles with equal spaced increments, right? 4, 8, 16. And it turns out if you plot something that's growing exponentially on a scale where, like this, where the equal increments are ratios rather than units, you see a straight line if there's constant exponential growth. And that's exactly what we see in the United States. And so in some sense, this graph has been behind my entire career. I show it in every presentation I give, probably, because it's important to me. But it sort of says for the last 150 years, growth in living standards in the United States has been 2% per year, plus or minus something, and we just don't get very far away from a path with constant exponential growth at 2% per year. Okay? So this is an empirical regularity, a stylized fact. It's certainly not a law of nature. It doesn't have to be that way, and we know if we go back historically, it wasn't that way. But the question is, how do we understand a graph like this? Where does this stable exponential growth for 150 years come from, and what might the future hold? Those are questions that I've been concerned about. I think back to Bob's solo, we've understood that technological progress, the discovery of new ideas, must surely be behind economic growth. And then thanks to Paul Romer, we understood kind of exactly how that works, in that Romer highlighted that ideas are different from every other good in economics. Right, so the standard goods in economics that we study, think about a barrel of oil, or an hour of your accountant's time, or this classroom, or your computer, or your automobile, or your house. Standard goods in economics are fundamentally scarce, meaning if you're using it, I can't use it at the same time. Right? We're giving this lecture in this auditorium. No one else can give the lecture in the auditorium at the same time, and that scarcity is at the heart of economics. Okay? What Romer pointed out is that ideas are different. In some sense, ideas are infinitely usable, right? You invent them once, and then it's feasible for any number of people to use the ideas simultaneously. So think about the Pythagorean theorem, or Beethoven's Fifth Symphony, or the COVID vaccine, or the latest algorithms for artificial intelligence. You invent those things once, they never have to be reinvented again, and they can be used simultaneously, right? So 100 different AI labs can use the transformer architecture, this latest thing for machine learning, to build new AI models. You don't have to reinvent it. You invent it once, and then potentially everyone can use it. And that led to a profound implication for growth that it's not totally obvious on this slide, but I think it'll be obvious on the next slide. Living standards are determined by the total number of ideas we've discovered, not ideas per person. If you add one computer, you make one person more productive. If you want to make 1 million people more productive in the same way, you need 1 million computers. But if you want to make people more productive with ideas, you give one new idea, and that can make 1 million people or 1 billion people more productive, right? The latest design for a new computer chip or something. And so each invention potentially makes everyone better off. Okay, and that's the way these ideas being infinitely usable, that's the key property. You see how to connect that with that first graph I showed you when you think about the second link in these growth models, which is where do ideas come from? And again, it's not a surprise to any of us that ideas, they don't happen magically. They come from effort by people trying to invent new ideas. New ideas come from people. They come from inventors, from entrepreneurs, from researchers, and from the efforts that those people put forth. And so in the long run, the stock of knowledge, the total number of ideas we've ever discovered, depends on the total number of people who've ever searched for ideas. And this creates a link between the stock of knowledge or the stock of ideas and the number of people. And since income per person depends on the stock of ideas, and the stock of ideas depends on the number of people, income per person depends on the number of people. And that's sort of what I was referring to as this surprising link between people and ideas. And if we take the growth rate version of that expression, it says the growth rate of income per person depends on the growth rate of people. So the growth rate in living standards depends on the growth rate in the number of people searching for ideas. But of course, in the long run, the growth rate of the number of people searching for ideas is limited by the population growth rate. And so the growth rate of living standards in the long run, kind of at the world level, I think you don't want to apply this model country by country, but at the world level, the growth rate of living standards is tied to the population growth rate. And this gives rise to a bunch of kind of interesting features that I want to go through now. Pietro already mentioned Moore's law and transistors and semiconductors, so this is my favorite illustration of this theory. And that is, so here's another straight line on a ratio scale, 10, 100, a million, right? This straight line is at the heart of all of Silicon Valley and at the heart of, probably a third or more of the economic growth that the world's experienced in recent decades. This is sort of the famous point that the density of computer chips, the number of transistors that you can fit on a computer chip, seems to double every 2 years for the past 50 years. Doubling every 2 years corresponds to constant exponential growth. This straight line on this ratio scale is constant exponential growth. In this case, the growth rate is 35% per year, right? Incredibly rapid growth. And, this again is behind part of the economic growth that the world's experienced. The question I want to ask, though, is where does Moore's law come from? Again, it's not a law of nature. It's not that no matter what we do, the density of computer chips doubles every 2 years. Instead, this was much more viewed by the semiconductor industry as a goal, as a target. And they would engage in research to keep pushing Moore's law forward. And it turns out they throw ever-increasing amounts of resources at these hard problems to generate the growth in Moore's law, right? So Luis Garicano was talking about ASML, the company in the Netherlands that makes the machines that make the computer chips. And these machines are just unfathomably complicated with mirrors and lasers and chemical reactions that are beyond comprehension. In order to make one of those machines takes enormous amounts of research today relative to how hard it was to double the density of computer chips back here in the 1970s. So if you measure the amount of research devoted to pushing Moore's law forward, you see the green line. You see this exponential growth in the number of researchers, and in fact, it takes somewhere around 18 or 20 times more researchers today to generate that doubling of computer chip density than it did in the 1970s. So again, you see the constant exponential growth in blue, the 35% per year. How is that achieved? It was achieved by throwing ever-increasing numbers of researchers at this hard problem, at this increasingly difficult problem of advancing the science of semiconductors. Okay? An implication of this is if we ever stop growing the research, the growth rate would slow down. It's kind of like Lewis Carroll's the Red Queen model of economic growth from Alice in Wonderland. You have to run faster and faster just to maintain the 2% growth. And if you ever slow down, the growth rate itself would slow down. Okay? And so, why are we richer today than in the past? At some very basic level, it's because we have more people to devote to more research, which leads to more ideas, which leads to higher income per person. But again, you follow that chain of reasoning, and the number of people is a crucial ingredient into generating the ideas. And so the growth rate of the economy in the long run depends on the population growth rate itself. Okay? Now, what's the future of world population? This finally brings us closer to the topic that I wanted to talk about today. Well, my view, say, 10 years ago, which I think was the conventional wisdom among educated people, certainly not among experts, but among, typical educated people, you and me, I thought global population might level off at 10 or 12 billion people, and I thought a little bit about what that meant for economic growth, but I didn't think it hadn't risen to the level where I wanted to think about it. Then it turns out, you look at what demographers are doing. There was a book review that I read in The Economist of a book called The Empty Planet, and it made the point that if you ask demographers what the future of population growth is, well, you see fertility rates falling. We've known that for a long time. Matthias Dopke yesterday gave a great lecture on declining fertility. Well, fertility rates are plummeting, but in fact, they're below replacement now. And it's the level that turns out to matter a lot. And so the modern view, and this is partly why we're all here at this festival today. I think this is a big theme of the festival. The modern view is that fertility rates are below replacement. And so maybe the future is not one of global population leveling off. Maybe it's a future of global population growth turning negative and population declining. And so what does that imply about the future of economic growth? Right? That was this Empty Planet paper that Pietro referred to. So here's just the graph that I think we've seen multiple times at different sessions. Total fertility rates. How many kids per woman do people have on average in lots of different countries? And you could see the declining fertility. This is a well-known fact. Everyone's understood that fertility was declining. I think what I implicitly thought is that it would level off at 2 somehow. So 2 kids per woman means we reproduce ourselves and we get a stable population. But if you think about it, there's no reason why it should level off at 2. And in fact, it doesn't. Everywhere around the world, we see fertility going from 5 to 4 to 3 to 2, and then passing right through 2, so that the rich countries of the world as a whole today, a number of them here, you could say, Italy, better than I do, have fertility rates well below replacement. Sure, they're leveling off at some number, but country after country is leveling off below replacement. And so one way to think about this, South Korea being the famous example of 0.7 kids. So where is the bottom of the fertility? Well, just to help you think about things, if each family on average has 1 kid instead of 2 kids, then the population falls in half every generation. Right? Falling in half every generation, after 10 generations, you've gone down by a factor of 1,000. Right? So in the time since the French Revolution, right, if we let that time pass again, if we were to just keep having 1 child per family, we would go from 8 billion people to 8 million people, a 1,000-fold decline. And all of the world's population would look like London or Hong Kong or the San Francisco Bay Area, right, instead of this world of 8 billion people. So this is a profound change that seems to be baked into the way people behave currently, right? It's very much consistent with the past. Unless something profound changes, that's our future. And that's that's an interesting future. So what are the consequences of this for economic growth? So again, I told you this theory based on ideas that long-run growth in living standards, the 2% growth in US living standards per year, is partly because the number of researchers we're throwing at these problems has been growing, and that's partly because the population of the advanced countries of the world have been growing. And if my view prior to 10 years ago about the future of growth was based on that model, and if you think we're going to have population growth of 1% per year forever, and you could certainly question that, but if you thought for a long time we're going to have growth of 1% per year, you'd say, okay, this is kind of the expanding cosmos view of the world. We have growth in the number of people, and we have growth in the number of living standards, in the living standards of those people. So we have exponential growth in living standards for a population that grows exponentially. We fill the planet, we fill the cosmos with a bunch of people as rich as Bill Gates. And that seems like a very optimistic future. Okay? Unfortunately, it's not at all obvious that that's the future we're going to live in. Instead, the future seems to be one of negative population growth. And with negative population growth, we empty the planet of people. Right? It's literally the end of humanity. And as the number of researchers stops growing and starts to decline, economic growth comes to an end as well. And so this very different view of the future is that living standards stagnate. It's the end of economic growth, but also for a population that ultimately vanishes, the end of humanity. And so the really striking thing to me is that these two different futures, the only difference between those two different futures is whether families have 2.2 kids on average or 1.9 kids on average, right? 2 is an incredibly magic number for which of these futures obtains, and we seem to be currently living in this future rather than that future, and that's, I do agree with Pietro. I think that's a profoundly disturbing future to imagine. Okay, so that was my first point, this surprising link between population growth and growth in living standards and the potential consequences of negative population growth for our future. For my second point, I want to step back and ask, well, maybe part of the reason why this future is disturbing is that economic growth comes to an end. But a big part of why it's disturbing is ending humanity. Running out of people seems especially bad. And so to think about that, you need to move away from the typical economist's focus on economic well-being. So economists typically measure GDP per person, income per person, and I think that's a great measure. I've spent my life thinking about that measure. It's wonderful, but it does miss this important point about the number of people. And philosophers are much more comfortable than economists with thinking about the number of people. And so one of the lines that I read from these philosophers is there's a difference between making people happy, which is what economics is about, and making happy people, which at least philosophers sometimes consider. And so I want to bring the notion of making happy people into the study of economic growth and see what it implies. So back to Jeremy Bentham's the greatest good for the greatest number, right? You care about how happy people are, but you also care about how many people there are. Okay, so to make this much more practical, let's consider, a very salient example, Japan versus Mexico since 1960. Right, so Japan, as you know, is one of the growth miracles of the world, right? The average living standards in Japan today are 6 times higher than they were in 1960. Japan exhibited this incredibly rapid growth, basically starting in the 1960s and 70s and continuing until recent times. It's a canonical example of a growth miracle. Mexico, on the other hand, has below average economic growth. Even with below average economic growth, they've still tripled their living standards since 1960, but that's disappointing. We typically refer to Mexico as a disappointing growth performance. Okay, and that's the way economists kind of typically evaluate these countries. On the other hand, if you look at population growth, you get the opposite perspective, right? So Japan is one of the countries with very low population growth. In fact, they've only added 30% more people since 1960. So incredibly slow population growth. In contrast, Mexico tripled its population. Okay, so which country has done more to increase happiness, the greatest good for the greatest number? Not so clear. Per capita, Japan. Total population, Mexico. How do we combine these things? How should we think about that? So that's a recent research paper that I've engaged in with some co-authors. And you want a measure of growth that incorporates growth in living standards as well as growth in the number of happy, flourishing people. And it turns out if you write down some theory, you get a very simple expression for this broader growth measure. And the broader growth measure is the sum of the growth in living standards, growth in income per person, let's say, and growth in population, where there's this coefficient V that tells how do you value the population growth? How do you put it in consumption growth units or income growth units? What's the exchange rate when you're evaluating these outcomes? And the theory suggests calculating V based on how much people themselves value living. How much do you enjoy your life? A lot, it turns out. And Alex Moss was here last night talking about the value of life and how much we enjoy life. And the bottom line from all of this research is that lives are incredibly valuable. Okay, and so we'll use this high value of life to measure V, and then think about how to do this growth calculation in a broader way. So I think Alex used a $9 million value yesterday. The US government, so the Department of Transportation, the Environmental Protection Agency, today use numbers around $10 million per life for the average American. Okay, the average American is maybe 40 years old, maybe has 40 years of life remaining. So a $10 million value of life, if you divide by the 40 years of life remaining, corresponds to something like $250,000 a year per year of life. This is why I said, the data suggests lives are incredibly valuable, right? So if the way to compute this V in our theory is the ratio of the value of a year of life to consumption per person. And it's kind of, because we're in growth rate space, you need to divide by something like income per person or consumption per person to get the right V. And as I said, the value of a year of life is some number like $250,000. You divide that by per capita consumption in the US, some number like $50,000, and you get that coefficient V for the US today is a number around 5. Each year of life in the US evidently is worth around 5 years of per capita consumption. That's the units on this measure. Right? Lives are just incredibly valuable. And it's not me saying that, it's the US government saying that. When they're deciding how safe should we make our highways, how many pollution scrubbers should we put on the companies that are polluting in order to save the lives, the value of life they're using to make those decisions is exactly this one, 5 times per capita consumption. And as Alex said yesterday evening, this comes from studies in the labor market. You can decide, do I want to be a construction worker, which is dangerous, or do I want to be a janitor, which is safe? Implicitly, you're making a trade-off between income and lives, mortality rates, and it's that number that leads to this number. For countries that are less rich than the US, the V is lower, but only slightly. So for example, I looked at our calculations. For Italy, the V is around 4 instead of 5. A year of life is worth 4 years of per capita consumption. And the average country in the world, the V is around 3. Okay? But the point, kind of the surprising point, is when we do this calculation, we add income per person growth to population growth, the weight on population growth is a number like 3 or 4 or 5. Each percentage point of population growth is worth 4 or 5 percentage points of consumption growth for this broader measure. So you already know it's going to make a profound difference in how we evaluate growth. Okay, so let me show you a table just to illustrate these kind of calculations. So lots of numbers here. The United States, let's start with that. Income per person grows at about 2% per year. I already referred to that number earlier. That's the 2.2. Population growth in the United States since 1960, 1% per year. But remember, I told you the value of life is very high, a number like 5 today. And if you average back to the 1960s, it's more like a number of 4.4. So population growth itself adds 4.3 percentage points to the total growth measure, and 4.3 plus 2.2 is 6.5. So based on this broader measure, hey, how much welfare are we generating in the United States from higher living standards and from more flourishing people? It's 6.5% per year rather than the 2.2% per year we usually focus on. Okay, what about Mexico? Mexico, I said, was the growth laggard. So per capita income growth, 1.8% per year, below average. The world average is around 2 as well. Population growth, though, in Mexico was fast, 2% per year. And Mexico's poorer than the United States and Italy, but still a value of life averaging around 3.4. So this 2 percentage point of population growth adds more than 6 percentage points to Mexico's total growth to get 8.6. Mexico is one of the fastest growing countries in the world in terms of generating total welfare at 8.6% per year. What about Japan? So again, Japan has the fastest growth rate. This is actually consumption per person since 1960, 3.2. but only half a percentage point per year of population growth. Japan's relatively rich, so you'll want to multiply that by some number like 4, but Japan versus Mexico, you can see Japan ends up well below the average for the world. The average for the world is more like the United States, so Japan goes from being a growth miracle, a growth star, to being a laggard if you think about creating total welfare instead. And then I brought out the number for Italy just so you could see it. It's much closer to Japan, right? So 2.8% per capita growth, you know, really good, right? So post-World War II, the incredibly rapid growth that followed. But as you know better than me, incredibly slow population growth. And so because population growth gets such a high weight, you know, Italy also ends up well below average. And Germany, you know, even slower population growth and even slower total growth. So the point here is not to say that these total numbers are better than the per capita numbers. I think for different purposes, you want different numbers. But we've typically had this laser-like focus on the per capita growth rate numbers, and maybe we should consider the total numbers as well. It gives you a different perspective on how you think about economic growth. Clearly, the thing, and this is just the graphical version of the same chart. Here you can see the blue is consumption, the green is the contribution from population, and so the green's a huge part of the story for lots of different countries. One of the lessons that comes out of this second point is that because the value of life is so high, adding more people is very valuable. Okay? And so this kind of brings me to the last point, which is a current research project that I'm working on now. So everything I'm going to say now is even more speculative, both in general, but also because the work's not completed. So we're working on this as we speak. And the question is, okay, if from the second point you take that people are very valuable, and from the first point you take that, hey, we're currently heading for this empty planet, a natural question to ask is, well, what should we do? And should is very much a loaded word there, and we could have lots of discussion about what do we mean by should, and I'll show you what I mean here, and it's more just, you know, for different ways you interpret should, what does the outcome look like? Okay, so I want you to imagine a world of 100 billion people, right? And you might think, wow, you know, that's just way too many people. The world would be incredibly crowded. Think of the pollution. And there's a lot to that point. On the other hand, perhaps it's not as crowded as you thought. This was the calculation. So imagine you took 100 billion people and put them all in cities the density of Paris, or now that I've been here, Torino. Torino, you know, in my mind, Paris and Torino have kind of the ideal density, right? You've got these nice shops, nice restaurants, beautiful places to walk. Life seems very good in Torino and Paris to me, and so that doesn't seem too dense. So the question is, what fraction of the world's habitable land would be taken up if we had 100 billion people in cities the density of Paris? And it turns out 5%, right? The world's a huge place. We have tons of empty land, and you could put 100 billion people in cities like Paris and still have 95% of the land left over for the beautiful beaches, the beautiful parks, the beautiful scenery, the beautiful canyons, the beautiful Alps. You're not overcrowding the world at all with 100 billion people. Another question, how would we feed all these people? Right? How much more productive? So it turns out the Netherlands is incredibly productive in agriculture. Again, probably as you know better than me, very little land, but incredible production of agricultural products. So how much more productive than the Netherlands today would we need to be to feed 100 billion people at some point in the future? Say it's a century or 2 centuries, I don't know, a long time from now. How much more productive? It turns out if you want people to eat meat, then you need to be 30% more productive than the Netherlands today. And that seems well within reach of a century of economic growth. On the other hand, if you're content with a vegetarian diet, current productivity of the Netherlands is already sufficient to feed 100 billion people. Okay, so this world of 100 billion people, what I liked about these calculations, it's not nearly as remote or preposterous as my initial instinct was. And I think everyone's initial instinct is that, oh, that's way too many people. But it's not obvious that it's way too many people. And certainly with technological progress over the next century, it's eminently conceivable that we could support a world of 100 billion people. So this leads to the paper. And in the paper, we ask this question: what's the optimal population in the long run? How many people should we have in the world? Is it 8 billion? Maybe we're at the optimum today. Is it 10 or 12 billion? Is it the empty planet? Maybe the empty planet is optimal. Or is it some number like 100 billion? And we tried to make a list of all the forces that we thought were relevant for thinking through this. And then we tried to build a model that has a lot of those forces. And then we try to think about what the model says empirically. Okay, so what are some factors that we consider? Well, the first is this empty planet factor. On the one hand, very clearly, parents have kids because we love them, right? All our parents love us, and that's why they brought us into the world. On the other hand, evidently, the love of kids is not strong enough to deflect us from the empty planet, because that's where we're headed, right? But that's one force. Parents love their kids. That's wonderful. Second force, the one that I started with today, more people means more ideas, and more ideas makes everyone richer, right? And so one reason to add more people is because it's going to make all of us richer, and that seems like a good thing. There's no trade-off in the short term in that space. More people raises living standards. The third bullet point is this Jeremy Bentham point about total utilitarian. Happy, flourishing people are socially desirable, independent of how the parents feel. Okay? So my co-author on this project, Pete Clino, comes from a family of 10 kids. He's child number 10 of 10. Okay? My guess is his parents were indifferent as to whether, they love the first 8 kids a lot, right? But by the time you get to 10, it's like, okay, we got a lot of kids. So his parents maybe were indifferent, maybe not. Pete loves existing, right? Independent of how his parents feel about him. And so again, you and I love existing. Palo Alto is a great place. Torino is a great place. Presumably, having more people come into the world, they would also love living in Torino and Palo Alto. And so that's this total utilitarian point of view. And then fourth, sustainability issues. This I haven't talked about yet, but this is going to turn out to be very important. Think about resource depletion, climate change, diversity loss, physical space per person, I already talked about a little bit, and pollution. Ultimately, we have a finite planet. And one of the things that's going to come out of this project is that economic growth comes to an end no matter what. We can't grow exponentially forever. In the model I'm going to write down, growth comes to an end. And the question is, does growth come to an end where we're all as rich as Bill Gates, or all as rich as we are today, or maybe even poorer than we are today? That's kind of the future we're thinking about. The poorer than we are today might surprise you, but let me come back to that in a second. And then a last point that turns out to be incredibly important. It won't be really reflected in what I'm going to show you for the next 1 minute before my time's up. There's a question of individual freedom. So if we think people are only having 1 kid per family, and we think somehow the empty planet is a bad outcome, so we want to encourage people to have more kids, to what extent is it morally acceptable to subsidize people to have more kids and push them away from their private choices? Well, a carbon tax is a tax that pushes us away from our private choices, and we think that's fine. But, the subsidy has to be paid somehow, so we're taxing people to subsidize them to have kids. Evidently, it's very hard to get them to have more kids, so it might require big subsidies. To what extent do we find it acceptable if families want to have 1.3 kids on average, and we want to get them to go to 2.2, is that okay or not okay? And that's a question we look at in the paper, but I don't have a lot to say about it today. But I think it's an interesting question. Okay, so let me just show you a couple of simulations from a model, and don't take the numbers seriously at all, but I think the idea that comes out is kind of right. So the purple dot is where we are today. Our consumption per person, I'm calling today 1. So how happy are people in the world today on living standards? Call that 1. And then the green dots are, and the blue path is this future where population. So we're at 8 billion people today and a consumption of normalized to 1. It turns out you want people to have more kids so you can get up above that magic number of 2 in this simulation. And that requires pushing people's living standards down by 2%. Okay? That seems reasonable to me. Carbon taxes would do bigger things than that, and we're comfortable with carbon taxes, so maybe that's okay. You get people having more than 2 kids, and the population grows. Because people produce ideas, living standards grow as well. So there's no trade-off in the short run. Population grows and living standards grow. But you'll see eventually it levels off at 41 billion people, and living standards that are 14% higher. And then actually, in this simulation, it turns around, and we keep adding people and living standards fall to where we settle down at a world of, 80 billion people and living standards 10% higher than they are today. Okay, that's one possible future that one can see in these simulations. Now, you might ask, as I did, well, I thought people producing ideas was incredibly important. We're adding all these people, we're 10xing the population. Why are living standards only going up by 10%? Surely, if this explains historical growth, they'd go up by more. Well, this is where this sustainability issue comes into play in the model. And what's built in here is that, the way I like to think about it, there's a certain amount of lithium on the planet. And to do all the computing and the electric vehicles and everything else, we need a certain amount of lithium per person. That's finite, and so that's going to constrain growth. And as we add more people, there's more pressure on the lithium, and that's going to ultimately constrain. Well, what you can see here is what share of GDP gets paid to natural resources. And you can see today it's around 5%, but it rises and rises and rises, and that's what slows growth down. And in this simulation, it can go up to 80% of GDP. So you can see how the sustainability issues are absolutely crucial here. Okay, I need to stop. Last slide. So the points I've made, our current path is an empty planet. That's where we're headed. Living standards stagnate for a population that vanishes, and this is the end of humanity. And that, to me, is a disturbing future. Interestingly and importantly, it's a choice, and we could make a different one. And so what I've tried to do is explore how we might want to think about those choices in the future. And I don't think I've really come to any conclusions, except I've realized that there are a bunch of factors that are important, and it does seem to me possible to have a much better future with more people and, in fact, living standards that are higher. So for a long time, I think there's not even a trade-off there, even if in the long run there might be a trade-off we want to consider. So thank you very much.
Super, thanks. Grazie. So,
thank you. So I promised you to have a sort of science fiction lecture, but it was actually a scientific lecture completely. And
nice things. Divertente nella vita, cioè pensare a
so it's so nice to think about these things in the long run, and is definitely the number one in this. And as usual, whenever I read his papers and his results, obviously we had to study all these things, and so that's why such an excellent researcher. So I know that lots of questions from the public. So I can see 3 raised hands here. So we'll be asking.
So fascinating work. I was thinking about this example that you showed about Japan and Mexico, and so I was thinking, in some sense, you started by saying that ideas can flow freely, and if you think of like a quality-quantity trade-off in fertility, it seems that Japan has actually produced way more ideas probably than Mexico. So it's also fascinating to think that countries could cross-subsidize each other. Like Mexico generates population growth, and and Japan does less of that, but instead produces sort of researchers.
Yeah, no, I think that's an excellent point that I completely agree with. Something that didn't come out enough in my talk is probably related to what you were saying, which is, the average living standards in the United States and in Italy and in Hong Kong and in Mexico depend on ideas created throughout the world. Ideas flow across borders, and so in some sense, we don't care where the idea is invented. You don't care that the iPhone was invented in Silicon Valley, you care that you have the iPhone. The iPhone raises your living standards. And so I think that very much underlies all of this. And the calculations I was showing really just came, there's kind of the production side and the utility side. These were all about the utility side and just evaluating outcomes, not saying where they came from. But I completely agree with what you said.
Thank you for your talk. So I think my question is similar to Giovanni's. So so you were saying that ideas move freely, but I don't know to what extent Mexico's population growth is generating new ideas that are being produced in Japan. I can't imagine right now the production function that leads to that scenario, right? So the countries in the graph that you showed, the countries that are still above replacement rate, which are developing countries. In those developing countries, I don't know how many, if enough, ideas are being generated. We've seen in this festival lots of talks about equality of opportunities, right? So I guess in much of these countries there is, for now, enough population growth, or at least above replacement rate, but not with the opportunities, with the education required to generate enough ideas. So unless there is more freedom of movement for population, more freedom of migration, for instance, this crop subsidization of population to ideas from country to country is going to be difficult.
Yeah, no, I certainly agree. That's an excellent point. The way I would put it slightly differently to help answer your question is, think about China in 1980 versus today, or think about India. Right? So each of China and India is 1.3, 1.4 billion people. In 1980, you would have said about China, oh, they're even poorer than Mexico. All of these people, they're not producing ideas, and but what we know is that the reason countries are poor is also a choice, right? It's related to institutions and policies, and we're making bad choices. Perhaps immigration could help on that front, but those choices can change, and in China and increasingly in India, those choices have changed. So now these billion people in China are absolutely producing ideas, right? Solar panels, drones, AI. China is one of the leading countries in the world at generating high-value patents and high-value scientific publications. And so I think just because Mexico's not producing ideas today doesn't mean that in the future these people or their children or their grandchildren won't be producing ideas. And so in some sense, you accumulate the people slowly, and we'd like a world where everyone's rich. We need to change those policies for sure. But over time, a larger fraction of the countries of the world have gotten on the growth escalator and become rich. And it does seem like the dynamic is, very few countries, we do have examples, Venezuela being an example. We have examples of countries that go from rich to poor, but by and large, countries disproportionately go from poor to being rich, and I think that's another reason for optimism about the future, but excellent point.
Excuse me. I speak in Italian because io ho avuto un'operazione.
I'm so sorry. I'll prefer to speak in Italian. So I do not want to show off, but I would like to briefly introduce myself. I am a researcher of the Italian Ministry of Culture, and we are studying just that. In order to reassure young people, I have to say that in Italy, we are not worse off than in the rest of the world. So Italy is now at the bare minimum of growth. This never happened before. I have two daughters. They have their degree, and I graduated from here, from Turin. So we are average because I have two kids. Italy is bound to grow. We will have more jobs. I believe in 2022 in Palazzo Madama, I was working for the ministry, and we had a demonstration with robots, using robots within museums to help out visitors. So when you are introducing robots, you're introducing technicians and engineers. Therefore, you are creating jobs because you need someone to simply work with the robot for maintenance. So now I'll get to my question. So that is very basic. So having children, promoting population growth. We spoke so much about artificial intelligence replacing us, taking all of our jobs. But we have technicians and engineers behind AI. So I have lots of followers on Facebook, I have to say. And, well, follow me and let's speak about these topics.
I think your point about artificial intelligence in robots is a very important one. And in fact, I would say my research agenda currently, half my research is on population, and the other half of my research is on AI and its implications for the future of economic growth. And I do think, you know, if you asked what could make the, I don't see them as predictions, but what's the most important thing that's left out of this analysis that could completely change the way we think about the world, I think artificial intelligence is absolutely that thing. And I think it's, I would even go so far as to say, you know, when I spend time on my population growth research projects, I feel guilty because I feel like the population growth projects have a horizon of 50 years or 100 years, and the AI projects have a horizon of 2 or 5 years. And so I do think it's incredibly important and very much could alter the picture that I've displayed for you today.
Sì, due velocissime.
Okay. So,
30 secondi a testa.
Two quick questions, 30 seconds each.
I liked a lot the fact that you included also a graph on the use of natural resources. I was wondering if maybe you did something also on emissions, because I think that's a bit the missing part. And for example, you quoted Bill Gates. You know, he made a nice scheme saying that the total emissions that we produce is number of people by services by how much we pollute per services. And unless we bring one of these to zero, it will never be zero. So in your kind of story in which, and I think it makes sense, you know, we might need more people, how do we add in the big picture the fact that unless we bring the emissions to zero, I mean, the whole story cripples down.
Yeah. No, as I mentioned on an earlier slide, the emissions and climate change is another piece that we're in the process of including. We've come up with some ways to include it, but I don't have simulations for you today. But absolutely, it's an important piece. The kind of things that you have to think about that, you know, in the trade-offs, on the one hand, I think technological progress is really helping us a lot. So solar energy, wind energy, nuclear energy, there are lots of clean sources of energy that can solve those problems. I think in many ways the climate problems are a political problem rather than an economics problem or a technological problem. I think we already have the technologies that can go a long way. You see emissions per person in rich countries falling, right? So we're making progress already. With the right carbon tax, we could make a lot faster progress, and it's really a question of political will rather than economics. So I do think it's going to matter for this analysis. I think in the simulations we've done so far, the climate stuff matters less than these natural resources, in part because of what we were just saying. The climate stuff is solvable, and when we talk about optimal population, we're kind of assuming we do the right thing with respect to climate. Now, it's an interesting question. If we don't do the right thing with respect to climate, how does it change these numbers? And we'll certainly explore that as well. Thank you.
Tommaso, last question?
Yeah. Thanks for your lecture. I'm not too familiar with this literature, but I assume that the share of researchers across time stays constant. And then if you have population growing, you have researchers growing. I was wondering, in light of what's happening in the US, how worried are you that the shrinking research budget will impact US growth? Or is it too little still, as the amounts cut to have a serious effect? Or how do you think about this?
Yeah, so another fascinating fact, if you look at what fraction of GDP do private firms spend on R&D in the United States, that's rising and rising and rising. It's still only 2% of GDP today, but it used to be less than 1% and less than 0.5%. So in fact, it's not constant, it's rising. And that's an interesting fact as well. And the fraction of GDP devoted to research all around the world is rising. So yeah, so that's just an interesting fact. Yeah, I think many academics will tell you the things going on in the United States now with respect to, research, seems like a terrible thing, and hopefully hopefully that won't come to pass. But yeah, who knows?
Ok, so l'ultimissima, ok, dobbiamo chiudere.
So we have to wrap up. A final question, very quickly.
Sorry, in Italian.
I am a bit shocked. I'm a bit shocked, really, because what we are teaching in school is that sustainability is a fight of the 21st century, of the next 10, 20 years. But we are still teaching to our young pupils that sub-Saharan Africa is in the second phase of the demographic transition. Maybe it's a too old concept that we are pushing onto the young generation. So the real challenge is here and now. We have an imbalance between population and resources, even locally. And I believe this model that you suggested sounds like science fiction, really. How can we think so far in the future when we have immediate emergency that we need to tackle now in the next 10 years?
Yeah, no, thanks. I do agree that it feels like science fiction. It feels like science fiction to me, too. I think sometimes it's important to engage in science fiction to think about the future, so that's the spirit in which I launch it. Absolutely, the world has tremendous problems. I think, for the most part, many of the world's problems, certainly sub-Saharan Africa, is a problem of policy and institutions rather than a problem of natural resources. The climate stuff is a problem, but I think the kind of problems we have, and one way to see it, I think, on this chart, what share of GDP is paid for all our natural resources, our finite land, our finite lithium, our finite oil? It's around 5% of GDP. It's surprisingly low. And that share is what tells you what are the limits to growth. And the fact that that share is so low says we've got plenty of room to grow now, because the idea effect. So people put pressure on natural resources, that's bad. People create ideas, that's good. The idea effect seems to be larger. If I put it on this graph, it might be at 25% or 30%. So you kind of have to wait until those lines cross before it's a problem. But it's not at all to deny that. I think many of the problems of the world today are problems of policy and institutions. And yeah, that would be my way of squaring some of these things. But thank you for the question.
Okay. Grazie, dobbiamo concludere.
Thank you so much. We need to wrap up. Thank you for being with us.